Earth Science, Chapter 6, Section 5, Renewable Energy Sources, Solar and Wind. Digging deeper. Solar energy. Forms of solar energy. There are different forms of solar energy. These include direct and indirect solar radiation, wind, photovoltaic, biomass, and others. Tidal energy is produced mainly due to the Earth-Moon system. However, the Sun contributes to the tides as well. There are three forms of solar energy with the most potential. One is solar thermal. This is direct solar radiation to make electricity. The others are wind power and photovoltaic cells. Solar energy is produced in the extremely hot core of the Sun. As you learned, this occurs through nuclear fusion. This is a process whereby hydrogen atoms are fused together to form helium atoms. A very small quantity of mass is converted to energy in this process. The ongoing process of nuclear fusion in the Sun's interior is what keeps the Sun hot. The surface of the Sun The surface of the Sun, although much cooler than the interior, is still very hot. Like all matter in the universe, the surface radiates electromagnetic energy in all directions. This electromagnetic radiation is mostly light, in the visible range of the spectrum. However, much of the energy is also in the ultraviolet range, shorter wavelengths, and in the infrared range, longer wavelengths. The radiation travels at the speed of light. It reaches the Earth in about 8 minutes. Earth is small and very far away from the Sun, therefore only a very small fraction of this energy reaches Earth. However, it is far more than enough to provide all of Earth's energy needs. Excuse me. However, it is far more than enough to provide all of Earth's energy needs if it could be used in a practical way. The Sun has been producing energy in this way for almost 5 billion years. It will continue to do so for a few billion years more. Solar energy that reaches Earth is spread out over a large area. Therefore, capturing the Sun's energy is not easy. In any small area, it is not very intense. The rate at which a given area of land receives solar energy is called insolation. Insolation depends on several factors. These factors include latitude, season, time of day, cloudiness of the sky, clearness of the air, and slope of the land surface. If the Sun is directly overhead and the sky is clear, the rate of solar radiation on a horizontal surface at sea level is about 1,000 watts per square meter. This is the highest value insolation can have on Earth's surface. If the Sun is not directly overhead, the solar radiation received on the surface is less. When the rays from the Sun are not direct, there is more atmosphere between the Sun and the surface. Some of the some of the radiation is absorbed before it reaches Earth's surface. Insolation decreases when a surface is not perpendicular to the Sun's rays. This is because the surface presents a smaller cross-sectional area to the Sun. Earth rotates on its axis once a day. It also revolves in an almost circular but slightly elliptical orbit around the Sun once a year. Earth's rotation axis is tilted about 23.5 degrees from the plane of Earth's orbit around the Sun. It points toward the Sun at one end of its orbit and away from the Sun at the other end. In the northern hemisphere summer, when Earth's axis points towards the Sun traces a path high in the sky. The hours of daylight are long. In winter, the Sun's path across the sky is much closer to the horizon. The hours of daylight are short. This has important effects on seasonal insolation and on building designs. Solar heating. Home heating is one of the main uses of solar energy. There are two basic kinds of solar heating systems, active and passive. In an active system, special equipment in the form of a solar collector is used to collect and distribute the solar energy. In a passive system, the home is designed to let in large amounts of sunlight. The heat produced from the light is trapped inside. Passive systems do not rely on special mechanical equipment. However, they are not as effective as active systems. Water heating is another major use of solar energy. Solar water heating systems for buildings have two main parts. They include a solar collector and a storage tank. The solar energy is collected with a thin, flat, rectangular box with a transparent cover. The bottom of the collector box is a plate that is coated black on the upper surface and insulated on the lower surface. This is shown in Figure 2. The solar energy that strikes the black surface is converted to heat. Cool water is circulated through the pipes from the hot collector box to a storage tank. The water is warmed as it passes through the collector box. These collectors are not very expensive. In sunny regions, they can provide most or all of the need for hot water in homes or swimming pools. Many large commercial buildings can use solar collectors to provide more than just hot water. A solar ventilation system can be used in cold climates to preheat air as it enters a building. The heat from a solar collector can even be used to provide energy for cooling a building, although the efficiency is less than for heating. A solar collector is not always needed when using sunlight to heat a building. Buildings can be designed for passive solar heating. These buildings usually have large south facing windows with overhangs. In winter, the sun shines directly through the large windows, heating the interior of the building. In summer, the high sun is blocked by the overhang from shining directly into the building. Materials that absorb and store the sun's heat can be built into the sunlit floors and walls. The floors and walls then heat up during the day. At night, they slowly release the heat. Many designs for passive solar heating also provide daylighting. Daylighting is simply the use of natural sunlight to brighten up the interior of a building. Solar water heating can reduce the use of fossil fuels. Heating water using fossil fuels is only about 60% efficient. Electric water heating is about 90% efficient. However, the production of electricity from fossil fuels is only 30 to 40% efficient. Reducing the use of fossil fuel for water heating also eliminates the air pollution. Photovoltaics. Generating electricity is another major use of solar energy. One common way is to use photovoltaic or PV cells. These are used for many purposes. They are used to power toys, calculators, and roadside telephone call boxes. PV systems convert light energy directly into electricity. These systems are an important part of your lives. They are known as solar cells. Very simple systems power some of the things you might see. Some examples are small calculators and wristwatches. More complicated systems provide electricity for other purposes. Some examples are pumping water and powering communications equipment. Complicated systems are also used to light homes and run appliances. In a surprising number of cases, PV power is the cheapest form of electricity for performing these tasks. The efficiency of PV systems is not high, yet it is increasing. New materials are being developed for conversion of sunlight to electricity. The use of PV systems is growing quickly. So, the solar panel that is made up of a number of solar cells. Solar collectors on roofs of buildings can be used to provide energy for heating water and regulating indoor climates. Photovoltaic or PV systems have disadvantages. First, direct sunlight is not regular. This makes the yield less predictable through the year. Solar panels also require other equipment. For example, converters are needed to transform direct current to alternating current. For continuous power, large batteries need to be used. These can be expensive. Solar panels are also inefficient compared to other energy sources. Their installation requires large areas. Between 2010 and 2013, federal subsidies for the installation of solar power rose 500%. Subsidies can be tax incentives. They also include reductions in interest payments on loans. This was more than 300 times the subsidy on fossil fuels. Wind power. People have been using wind power for hundreds of years to pump water from wells. Yet, it has only been in the past 35 years that communities have started to use wind power to produce electricity. Figure 4 shows wind turbines from an electricity generating wind farm near Palm Springs, California. The triple blade propeller is one of the most popular designs used in wind turbines today. Wind power can be used on a large scale to produce electricity for communities. It can also be used on a smaller scale in households. Figure 5 below shows typical wind velocities in various parts of the country. Texas leads in the generation of electricity from wind turbines. In 2016, it had a wind power capacity of 18,531 megawatts, with several tens of thousands of wind turbines. Other areas in the country have a high potential for wind power as well. These areas include the Rocky Mountains, the flat Midwest states, Alaska, and many more. Commercial wind turbines can have blades with a diameter as large as 60 meters. Wind turbines have several disadvantages. Many people find wind farms to be unattractive. They can also be noisy. This means that they need to be located away from residential areas. Also, winds are unpredictable. However, winds are more continuous in coastal regions. In those areas, wind turbines can provide a more constant source of power. In places where hurricanes and tornadoes occur, wind farms cannot be used. Between 2010 and 2013, federal subsidies for the installation of wind power rose 9%. This amounts to about 50 times more than the subsidy on fossil fuels.